Hello everyone, and welcome to another episode of Cabinet of Curiosities on our own devices. I'm Jean Messier, and today we are diving back into the terrifying world of chemical warfare. You'll recall a couple of videos ago that I had a look at some gas masks and other anti-chemical warfare equipment issued to civilians during the Second World War. Well, today we're going to be skipping about a decade forward in time as part of an ongoing series on NBCW, or Nuclear, Biological, and Chemical Warfare Equipment, issued to Canadian military and civilian personnel during the Cold War era. And to get us started, I have a pair of really neat pieces of kit here. This is an L1A1 and a C2 chemical agent vapor detector kit. So these are essentially small portable chemistry sets meant to be used by a soldier in the field to determine what, if any, chemical warfare agents they've been attacked with. And these are really complicated to use. They're really neat little pieces of equipment. But before we can get into the nitty-gritty of how these work, as always, a little bit of background. So the belligerent nations went into the Second World War with essentially the same chemical weapons they had developed during the First World War, albeit with a couple of minor upgrades. And these fell into three main categories. There were tear gases like xylyl bromide, which irritate the mucous membranes and the eyes. There were choking gases like phosgene and chlorine, which irritate the respiratory tract and which essentially cause you to drown in your own fluids. And finally, there were vesicants or blister agents like mustard gas and lewisite, which are oily liquids when splashed on the skin, create very intense and painful chemical burns that take a long time to heal. And although all of these agents had been banned by the 1928 Geneva Protocol, most nations ignored this and continued to stockpile large amounts of these chemical weapons throughout the 1930s, although for various reasons, most were not used during the Second World War. But this landscape would start to change in 1936 when a chemist named Gerhard Schrader, working for German industrial giant IG Farben, started experimenting with a class of chemicals known as organophosphates in an attempt to create a more effective insecticide for German agriculture. And one of the compounds he came up with turned out to be extraordinarily effective. In fact, it was far too effective. It was thousands of times more potent than it needed to be an insecticide, and was far too dangerous to humans to be used for its intended purpose. However, the German military quickly realized that this would make an ideal chemical warfare agent, and so in 1939 they established a pilot factory in Poland, and in 1942 started manufacture of this compound under the name Tabun. And tabun in German means taboo, a reference to just how dangerous and how illegal this compound was. So tabun was the world's very first nerve agent, which is a class of chemical weapons that work by incapacitating the central nervous system. So when a nerve impulse needs to jump from one neuron to another, or from a neuron to a muscle or other organ, it needs to cross a small gap known as a synapse. And this is accomplished using special chemical messengers known as neurotransmitters, including one called acetylcholine. So one neuron will emit acetylcholine, which will transfer over across the synapse and lock into special receptors on the other side, transferring the signal. But once a neurotransmitter has accomplished its task, it then needs to be deactivated and removed. Otherwise, the neuron will continuously fire, and muscle coordination, for example, would be impossible. And this is accomplished using an enzyme known as acetylcholinesterase, which goes in and removes the acetylcholine molecules. What a nerve agent does is interfere with acetylcholinesterase, which means that as soon as a neurotransmitter has crossed the synapse and locked in place, it stays there, it never gets removed, and so the neuron continuously fires. And when all the neurons in the body fire all at once, you get muscle spasms and convulsions, and the whole body just shuts down, and eventually you die. And these types of weapons are particularly powerful because unlike, say, something like phosgene, where you need to breathe in a significant quantity, or mustard gas, where you need to spread a lot of it on a person's skin to incapacitate them, a very, very small amount of nerve agent vapor dropping on the skin is enough to kill a full-grown human. So the Germans really had something powerful on their hands. And they would continue to investigate organophosphate compounds and come up with three more, known as sarin, soman, and cyclosarin. And the factory in Poland would produce around 12,500 tons of tabun, and other factories would produce a couple thousand tons of the other chemical weapons before the end of the war. but none of them were ever used before the conflict ended. After the war, however, the Allies investigated the German chemical weapons program and were very impressed, and many nations integrated nerve agents like sarin into their own arsenals. And in 1952, Imperial Chemical Industries in the United Kingdom would develop one of the most potent and most widely used nerve agents of all time, known as VX, originally standing for Venomous Agent Unknown, or X. And weapons like these have been used intermittently for the rest of the 20th and 21st centuries, most famously by Saddam Hussein against Iran and the Kurds in the 80s, and by the Japanese doomsday cult Aum Shinrikyo in their attack on the Tokyo subway system in 1995. Now, in addition to nerve agents, a number of other newer chemical weapons were developed in the immediate post-war era, which meant that by the 1950s, the average soldier had a bewildering array of very nasty chemical weapons to contend with on the battlefield. And these included tear gases, including bromoacetone, or BA, bromobenzyl cyanide, or Ca, chlorocetophenone, or CN, dibenzozazepine, or CR, and orthochlorobenzylidine malodonitrile, or CS. Vomiting agents, including adamsite, or DM, diphenylchloroarsine, or DA, and diphenylcyanoarsine, or DC. Incapacitating or psychological agents, including 3-quinylnucleotyl benzoate, or BZ, phenylcyclidine, or SN, lysergic acyl diethylamide, better known as the drug LSD, and a fentanyl-derived Russian compound known as Kolokol-1. There were also vesicants, or blister agents, including nitrogen mustard, or HN, sulfur mustard, or HD, and lewisite, or L, utricants, or nettle agents, which produce a painful rash on the skin, the most common of which is phosgene oxime, or CX, blood agents, which interfere with the blood's capacity to carry oxygen, including cyanogen cyanide, or CK, hydrogen cyanide, or AC, and arsine, or SA, choking agents such as chlorine, or Cl, chloropicrin, or PS, diphosgene, or DP, and phosgene, or CG, and finally nerve agents including tabun, or GA, sarin, GB, soman, GD, cyclosarin, GF, or the V series, including VE, VG, VM, and VX. And so you can see the need for kits like these to figure out what you were being attacked with. So let's actually open one of these kits and see how these would have worked. Right, so this is the L1A1 Chemical Vapor Detection Kit, or KVD, and this was developed in the 1950s, and this particular one is stamped 1955. And this was intended to be worn around the neck, just like this, leaving your hands free to manipulate the items on the inside. It has a pair of quick-release straps, like a lot of NBCW equipment, so you can very easily use it with big gloves. You can pop those out, and then the whole kit unfurls just like that. As you can see, we've got quite a complicated chemistry set on the inside. Let's have a closer look at how this works. So at the heart of this system is this little air pump stored in a pocket at the bottom. And this is very simple. It's like a little bicycle pump. It's got a rubber receptacle at one end for holding the little reagent paper buttons that are stored in these test tubes, as well as a sliding sunshade. And this is here because a lot of the chemicals in this kit are photosensitive, and so to protect them from exposure to direct sunlight, if you're using this in the field, you have to keep that extended. And this simply passes air over top of those reagent buttons, and thus any chemical vapor in the air. Now, the kit is actually pretty cleverly designed. It has a little pocket in the bottom here, that allows you to stick the pump in there, and thus allows you to use the pump single-handedly, leaving your other hands free to do other things. And yes, I'm very aware of what this looks like, so I'm going to give you a little minute to get it out of your system. Okay, done? Right, let's move on. So quite conveniently, this kit comes with a complete set of instructions in the form of this little booklet wired to the kit itself. And as you can see, each page has been laminated to prevent the paper from absorbing chemical warfare agents or just mud and other contaminants. And this gives very clear step-by-step instructions on how to use the kit. Now, this kit is designed to detect two types of chemical warfare agents, nerve agents and blister agents like mustard gas. And so let's actually go through the procedure for both to show how you actually use the kit. Right, so to test for nerve agents, the first thing you need to do is prepare your reagents. And so what you do is you pull out a clear tube and a yellow tube, and these contain the reagent chemicals in pill form. And all of the tubes in here are somewhat designed for use with big, heavy gloves. And so they've got a little slot in the top here, and you're supposed to tip the pills out, much as you would with, say, a Pez dispenser. But for my money, these are still kind of awkward to use if you're in a big NBCW suit. So I'm not quite sure how effective these were in the field. So what you would do is then you would take one of these little applicator tubes, which is made out of very flexible plastic. You pop the cap off. You put one of each pill from the clear and the yellow test tubes inside. You can then replace those in the kit. You then take water in this little amber bottle here, put that into the applicator tube, replace the cap, and then you would crush the pills inside to mix up your reagent mixture. So now you have your reagent. You then take your pump, you pull out one of the white tubes, and you pop out a little plastic button that has a piece of blotter paper inside. You then put that into the little rubber receptacle at the end of the pump. You take your applicator, now full of reagent, squeeze out a couple of drops onto that blotter paper until it's wet, close the sunshade, and then give it a couple of pumps. They recommend not more than 20. And if that little button turns blue, that means that there is nerve agent in the air. So that seems pretty straightforward, but when it comes to testing for mustard gas and other blister agents, the procedure gets a tad more complicated. So as before, you set up your pump in the vertical position, but instead of reaching for one of the white tubes, you instead reach for a red tube, which again contains a little plastic button with blotter paper, but the blotter paper in this case is already treated with a chemical reagent. So you pop that out, put that in the end of your pump, and then start pumping. However, if the filter paper turns blue before you've even started pumping, that could indicate the presence of some sort of acidic compound in the air. There still could be mustard gas, but you could be getting a false positive from this acid. So in order to rule that out, you then need to carry out a completely different procedure. So what you do is you reach for one of the orange test tubes, which contains not the little plastic buttons with the blotter paper, but rather a series of fine glass capillary or capillary tubes containing a buffer solution. And so you go to the little plastic loop on the front of the test tube carrier here, and you use that to break off both ends of the tube, being very careful not to spill the solution on the inside. You then very carefully touch the end of the tube to the blotter paper in order to wet it. You then discard the tube. You then open up one of the blue test tubes, which contains a filter button made of mauve blotter paper. You then insert this into the end of the red button, and then you start pumping as before. And if the mauve filter paper remains mauve, but you still get the blue color on the red filter paper, then that indicates the presence of mustard gas. So quite a complicated, fiddly thing to use. And you can see I'm kind of struggling, even though I'm not wearing heavy rubber gloves as I would be if I were using this in the field. So I'm not quite sure how really effective this was. You'd probably be fumbling around for quite some time being exposed to chemical weapons before you ever got any results. Thankfully, though, as time went by, the equipment and the techniques got a little more refined and a lot easier and quicker to use in the field. So the next piece of equipment I have to show you today is a later model C2 chemical agent detection kit. And this dates from around the late 1960s, early 1970s. Now this particular kit is stamped 1982. And although that was the year that Canada adopted the more modern Pattern 82 web equipment, the details of this, the type of strapping, the type of buckles, the Velcro on it, this is very distinctly Pattern 1964 gear. And this is simply because although the Canadian military did adopt Pattern 82 gear in 1982, it took quite some time, as it always does, for that equipment to reach all branches of the armed forces. And so for many years, even after the official adoption, they were still using Pattern 64 equipment. And we'll be looking at the rather fascinating history of Canadian military web gear in an upcoming episode. Now, this was a significant improvement over the L1A1 chemical detection kit, namely in the fact that you did not need this entire kit to detect the most pressing and dangerous of all chemical warfare agents, nerve agents. You didn't want to have to carry this around to tell you whether it was nerve agents in the air. You wanted something that was much more compact and convenient to use. So instead of this, they developed NAVD, or Nerve Agent Vapor Detection Paper. So this is just a booklet of little pieces of blotting paper that have been soaked in a chemical that reacts with nerve agents. And these particular ones have an adhesive backing. So say if you're in a gas-tight shelter, you can stick these up on the wall and they will give you an early warning of if any nerve vapor gets into the shelter. Now, these are extremely handy, but they do have one disadvantage in that in being a big booklet like this, unless you have them sealed inside a plastic bag, if you're just carrying this around in your equipment and you're exposed to nerve agent vapor, then the entire book is going to be contaminated and become useless. So this is an older pattern. They later came up with a much better pattern of NAVD where the blotter paper with the chemical reagent was contained in a little plastic holder, as you can see here. And to use this, you would pull it out of its envelope, you would crack it in half, push one little piece of blotting paper into the other, wet this using water from your canteen, for example, wave it through the air, and if the red blotting paper turned white, this indicated that there was nerve gas present. So a lot easier to use and a lot less susceptible to contamination. Now, interestingly, I actually have a funny story related to a NAVD like this. So quite a few years ago in the 1980s, my parents had a friend who was in the Canadian Armed Forces, and he came over to visit and he was showing them some of his equipment, including his NAVD. And just by way of demonstration, he pulled it out, cracked it in half, pressed it together, and waved it through the air. And the red blotter proceeded to turn white, as presumably did he. But my parents very nonchalantly explained to him that it must have been the malathion in the air. Malathion is an insecticide that we use quite a bit here in Winnipeg against mosquitoes. Today, they typically fog it from trucks, but in those days, they actually dropped it from aircraft. And so there's always a little bit of that vapor present in the air. And being an organophosphate compound, reacted with the NAVD to indicate the presence of nerve gas, giving that friend a particularly nasty fright. And on that subject, I actually have here some military issue insect repellent, which contains organophosphates and should set off the NAVD paper. So let's try it out. And yeah, you can see that is turning bright red. So this is exactly what my parents' friend or anybody actually encountering nerve gas would have seen. Right, so let's have a look inside the C2 chemical agent detection kit. So like the L1A1, this is meant to be suspended around your neck. And thanks to the miracle of Velcro, you can actually deploy this in a very convenient configuration, like so, which gives you easy access to the contents of the kit. So let's have a look at what's actually inside here. So just like with the L1A1 kit, the heart of the system is a little manually operated air pump. But unlike the L1A1, which used little plastic discs with blotter paper, this instead uses little glass tubes filled with chemical adsorbent, typically silica gel. So these are contained in this little dispenser, which is very much like a toothpick dispenser. And so how to use this is you pop out one of these tubes, you stick it in one of two little rubber-lined holes in the pump air through the tube about 10 times, and then you can take this tube out and apply a number of chemical reagents. So we have 4 color-coded bottles here. Some of these are you have to prepare yourself. So there's a little bottle here full of, they look like marshmallows, little pills with solid reagent. You put those inside the white bottle. You apply water using this little bottle right here, and then shake it up to create your reagent. Whereas in some of the others, they have little glass ampules where you fill the bottle with water and then you crush the ampule between your fingers and then shake it up to create your reagent. And then you take these bottles in sequence and apply them to the little glass tube, and the color changes tell you what sort of agents are present or not. And the other things we have in this kit are spare tubes in little foil packages, as well as an unknown agent envelope. So if your tests come out inconclusive, what you do is you pull out another one of those tubes, you pump air through it to collect whatever vapor is in the air, and then you put it in this little envelope and you mail it off to a chemical warfare expert officer who can then conduct more extensive tests to figure out what sort of weapons are in the air. And just like the L1A1, we have a convenient set of instructions on little laminated cards, but of course, this one also has it in French. And one of the funniest things I find about this kit is if you read the very first line of the instructions, colorblind people must not operate this kit. Very useful advice. So let's come in a little bit closer and let's see the procedure that you would have to go through to rule out different types of chemical agents. So opening up the booklet, you can see we have a rather convenient flow chart here. So the procedure would start by pumping air through a plain tube, and if the reagent inside turns yellow or orange, then that indicates the presence of cyanogen chloride, which is a blood agent. And this was actually developed by the Americans during World War II for use against Japanese troops in deep entrenched positions like bunkers. And although they developed all sorts of munitions with this chemical weapon, including bazooka rounds, they never used any during the war itself. Now, if there's no cyanogen chloride present, then you would then add a drop from the blue reagent bottle. If that turns blue, that indicates the presence of HN, which is nitrogen mustard, a vesicant. If it turns yellow or orange, that indicates the presence of CX, which is phosgene oxime. This is a nettle agent which induces a very painful rash on the skin. If neither of these are present, you then add 1 drop of reagent from the white cap bottle. If the tube then turns yellow or orange, this indicates the presence of AC, which is hydrogen cyanide, another blood agent. And then finally, you would add 1 drop from the green cap bottle, and if this then turns yellow or orange, this indicates the presence of CG, which is phosgene, a choking agent. So as you can see, this kit is a lot more streamlined and user-friendly than the old L1A1 kit and a lot of the intermediate kits, such as the M18. But it's still a rather cumbersome and fiddly thing to use, especially in full NBCW gear, where you have the big rubber gloves that make it hard to handle the smaller components of the kit, and a gas mask that makes it difficult to actually look down at the results. And so I can't imagine that this would have been very pleasant to use in an actual combat environment with suspected chemical agents in the air. And this is why the Canadian military and other militaries eventually switched to automatic detectors that use gas chromatography technology to be able to get a near instantaneous readout of pretty much any chemical warfare agent currently in use. Now, once you've determined what chemical agents are being used on the battlefield, you then need to take steps to protect yourself accordingly. And the Canadian military, along with other militaries, issued a vast amount of different types of equipment for this specific purpose. But unfortunately, that is going to have to await a future video. So this is all I have for you today. A big shout out to Gord Crossley and Dirk Darren for allowing me to borrow these really cool kits to show you today. I'm going to be continuing with the next couple of videos to show you NBCW equipment, both military and civilian, from the Cold War, so stay tuned for that. But until then, I'm Jean Messier from Our Own Devices. Have a great day.